Hello, welcome everyone. Welcome back to my channel. Today we are doing physics, and in that we are going to start astronomy, or you can say space physics for GCSEs. Obviously, this chapter starts with the solar system, but here today I'm starting it with the life cycle of a star. Just giving a very brief info of solar system, and then we'll move on to the main part of our solar system, which is our sun. But before that, I am starting the classes for GCSEs, A levels, and for all the years. That means from year 1 to year 13 for all the subjects. So I have a panel of experienced tutors. The rates are very minimal. It's just £10 per hour for one-on-one for GCSEs and for £15 per hour for A levels, and we are running discounts as well as of now. Plus for GCSE batches it's just £6 per hour, and for A-level batches it's just £10 per hour. And for all other subjects, what all you need to do is just email us at exactacademy@gmail.com, and we'll coordinate and we'll let you know everything, what all discounts we are running, what are the prices for one-on-one, for batches, and everything. So let me come back to this, which is our astronomy space physics. As I told you, we will start this with the solar system. This is our solar system. You can see at the very center is the heaviest and the glowing our sun right here. And all the planets are revolving around this one. This is Jupiter, this is Mars, this is Neptune, this is Earth, Venus, and so on. So we know that a system in which there is a heavy sun at the center, a star at the center, and the planets keep on revolving around it. Not only the planets, but other celestial bodies as well. That means asteroids, comets, you can say dwarf planets, they all keep on revolving around the sun because sun is the heaviest object. And here I have written the definition as per the paper. A solar system is a system of planets and other celestial bodies revolving around the sun. Now, I am starting with the sun, the center, the most important thing. Just like we have a whole life cycle, when you take a birth, for any living organism I'm talking about, you take a birth, then you grow up. You have a different life cycle, different stages of your life. You are a child, then you will become a teenager, then an adult, and ultimately you die as an old person. So this is whole life cycle, and similarly a star has its own life cycle, every stages through which it has to go. I'm starting with the first one, the initiation of the star, how it formed, and it's called nebula. The picture of nebula is given. It's quite glowing, and it's glowing purplish and the pinkish. And the definition that I have written here is a very dense luminous cloud of dust and gas. An initial friction results in joining of gas and dust particles. Now, what happens is, say for example, a star had died in supernova. Okay, I'll explain what supernova later as well, but it has died. What happens is, throughout the space, now the hydrogen gas and the dust particles are scattered. They are there, a little friction. The reason can be any, okay, but a little friction results in the joining of all the particles at one place. So a little initiation was required, that is a friction, and then all the gas particles, gas is hydrogen gas, that's important. So this gas that we are talking about is actually a hydrogen gas. So hydrogen gas molecules and the dust, that is the dead remains from, you can say, the different celestial body, they all start to come closer to each other, and they start to form a very heavy and a dense cloud. And that dense cloud, only up till here, that stage is your nebula. That formed part is your nebula. That's a birth one. It's just like a little baby, and it's just start to form. That's your nebula. Now here it's written in the definition, a very dense luminous cloud. Luminous, that means it gives off light. Light can be given off by two different ways. Nebula are of two different types. I'm not discussing the type here because that's not in your syllabus, but how it gets its light, that's important. So there are two types of nebula, one that have their own light, and second, those they reflect the light. Now obviously it's made up of dust particles, and dust particles are very good reflectors of light. So when the light coming from the different nearby star reaches to the nebula, the light gets reflected. See, for example, let me explain it here. This red one that I'm drawing, suppose is a star. So obviously a star has its own light, so it's giving off like this. And here this is your nebula, which is a very dense cloud of the dust. So these dust particles, when the light falls on the dust particles, they reflects the light, and then when they reflects the light, it becomes luminous. You will be able to see that nebula. So one reason is they reflect the light. So one type of nebula are they don't have their own light, they reflect the light. The other type of nebula are when they have their own light. What's happening is when all the particles are joining together, they are compressing each other, and on compression it creates a very high temperature, and because of the very high temperature, obviously the ionization of gas takes place and it starts to glow. So this is the reason of glowing for those nebula that have their own light. So what we can say, a very dense luminous cloud of dust and gas. And suppose the question is why they are luminous. So reason could be some nebula reflect the light of the stars, and some nebula which have their own light ionizes the gas and become luminous. So this is all about the starting stage of a star. A next stage is a protostar. A protostar is a young star. As you see, the definition that I have written is a young star which contracts under its own gravity. Its core is not hot enough for the fusion reaction. See, basically what happens in a protostar, it's the later stage of a nebula. Just after the sun enters in the life cycle, the stage that's called a protostar. What happens here inside it? Still the molecules keep on colliding with each other. We know that the gas molecules are always in a random motion. They are in continuous motion. Now think these as hydrogen molecules. They are just joining and sticking together, and at the same time they keep on colliding, they keep on vibrating. So this results in compressing them each other. They are exerting pressure on each other and are compressing, which results in obviously raising the temperature of this center. Now this thing that's written under its own gravity. Why now they are contracting under their own gravity? Because enough mass has accumulated now. The gravitational pull is directly proportional to the mass. That means heavier is the mass, heavier will be the or higher will be the gravitational pull. So if more and more mass is now accumulated, it actually increases the gravitational pull, and they start to you can say contract under their own gravity, under their own gravitational pull. There is a strong force now acting, which is a gravitational force. Now when they start to contract under their own gravity, they start to combine and become a more and more compact, more and more dense cloud. And this dense cloud is the particles are in random motion, which results in increasing the temperature and the pressure. So now it's hot, so that it's not hot enough to carry out the nuclear fusion reaction, but it is very very hot even though at this point of time. So now it starts to glow, whether any type of nebula was that, but this protostar will start to now glow. So this luminosity comes from the heating of the protostar when it starts to contract. So I'm again repeating, when it starts to contract under their own gravity, it increases the temperature, and the friction is constantly there, which results in raising the temperature of the protostar. Now they actually usually surrounded by the dust, and which it blocks the light that they emit, and sometimes they become very difficult to observe in the visible spectrum. So this was about the protostar. The next stage is the main sequence star, in which actually the fusion reaction takes place. The next stage is a main sequence star. As the definition written, a main sequence star is in which the hydrogen is converting into helium in its core, and all the forces outward and inwards are balanced. It continuously produces energy because of the nuclear fusion. Now, important thing is to know about the nuclear fusion. If we go back and see the protostar, the temperature started to rise because all the particles are now closer to each other. They are a compact dense cloud, and there is a constant friction which results in creating a very high temperature. But the temperature wasn't high, or the pressure wasn't high enough in the protostar to carry out nuclear fusion. This thing continues, and when a very high pressure and a very high temperature is achieved inside that, then the nuclear fusion starts to take place. So let me see what exactly the nuclear fusion and why it requires a very high temperature and pressure. See, these are the hydrogen particles at normal temperature and pressure. I have written at normal temperature and pressure, collision happens. That means they just come closer, they are just coming closer. This arrow is representing that they are approaching each other. And when they approach each other, they just hit it. They don't stick, they just hit it. Why they can't be there? Because there is electrostatic repulsive force between the nuclei, because nuclei are having the same, you can say, charge. So there is electrostatic repulsive force between the nuclei, and they can't be there, they can't be they can't stuck together, and they just hit it and then repel with each other and go back. Like this, after collision, atoms just nuclei just bounced back and they move away from each other. That happens in a normal temperature and pressure, and that's why fusion can't take place. Now let me see this one. They are hot enough, and that's why I represented it with orange color to represent that they are at very high temperature. So now when they start to approach here in the first stage, they are approaching each other. Now there is no more electrostatic force still. Well, electrostatic force is still there, but there is enough high pressure already there. So what will happen? A very high pressure is acting on it, and this high pressure is enough to overcome that electrostatic repulsive force, and now they are just stuck together because the force that are exerting, that is there, or the pressure that is there on the molecules, on the nuclei, are high enough to overcome that repulsive force. Now the repulsive force seems to be weaker as compared to the pressure there, and because of that repulsive force, they can't bounce back. They have to stuck together with the high pressure already created in a protostar, or at the very end stage of a, you can say, the transition phase, when the star is transiting from protostar to a main sequence star. What happens is the temperature and pressure continues to increase tremendously, and at one point the pressure increased so high that the electrostatic force or repulsive force can easily be overcome by that high pressure, and now all the molecules can stick together easily. They are at very high temperature that they just fuses together, and now when they just fuse, they start to, you can say, just like if two things at a high temperature and pressure, they start to melt and form one thing. Similarly, they are start to fuse and become a one heavy nucleus of helium when hydrogen fuses together? Well, it depends on different types of fusions, but that's the main process. When two lighter nuclei overcome the electrostatic repulsive force because of very high temperature and pressure, they just fuses together and becomes a very heavier nucleus. This is what happens in a star. Hydrogen they fuses together and forms the helium, and when this reaction starts, then the two forces will start to act in a star. One force is a gravitational pull, definitely because of a very heavier mass towards inside like this. And second is the force created by the nuclear fusion, because nuclear fusion creates a very high amount of energy. When anything happens with the nucleus, when it breaks or fuses or whatever happens, it actually holds a very higher amount of energy. And this energy in either nuclear fusion or fission, when something happens, it liberates a very high amount of energy and a very high pressure. So this nuclear fusion causes an outward pressure like this. This doesn't happen in a protostar. It happens after, you can say, a transition phase in which the protostar is converting into a main sequence star. The initiation of nuclear fusion happens in the transition phase. And as soon as the fusion reaction starts, the outward pressure starts to exert. And when these two forces become equal to each other, then it finally becomes a main sequence star. So don't say that the nuclear fusion happens in a protostar. Nuclear fusion, the initiation of the nuclear fusion starts in a transition phase. It has passed the protostar phase. Now the fusion starts to take place. There is an outward pressure by fusion, there is an inward by gravity. When they become equal to each other, then a main sequence star born. And this was what happens in a main sequence star, and that all I have mentioned in the definition. A star in which hydrogen converts into helium and all the forces are balanced. So a main sequence star is the most balanced one, and right now approximately 90% of the stars of our universe, how many stars are there in universe? The 90% of the stars are the main sequence star. And this is the longest phase of any star. So you can say like in its most of the life or the star is actually a main sequence star. This phase is quite longer as compared to the other phases of a star. Now from here there is a distribution of the life cycle starts. That means once this from nebula, protostar and the main sequence star, this life cycle is common for every star. Now the star changes according to the mass, and this I can show here. See the birth that is nebula and the protostar. See here one more thing I have written, that the nebulas are, like the protostars, are the young ones that we have already described, and I had described there as well that it's completely surrounded by the dust particles, and that's why you cannot detect it in a visible spectrum. But when it changes to main sequence star, it has cleared all the surrounding gas and dust. Now all the gas and dust are inside and takes participation in the nuclear fusion. From here, like the till main sequence star, it's exactly the same, but the phases changes now from here, and it all depends on the masses. See, if there's a star which is lighter and as compared to our sun, or is 8 times or lesser than the 8 times, will undergo all the life cycle that is mentioned on left hand side, like this one. Every life cycle it will follow. So what all? Those stars that are lesser or equal to 8 times the mass of the sun. So that means all the, I'm talking about stars that are very small or half the size of the sun, or twice or thrice the sun, or till 8 times the mass of our sun, they undergoes, or even our sun, they all will undergo this life cycle that I have mentioned on left hand side. Whereas those stars that are heavier than that will become whatever the life cycle I have mentioned on right hand column. They will undergo this life cycle that we will be discussing in our next video. Till then, just revise whatever I have explained to you. One more thing, if you want to access the free worksheets, this worksheet and the related question, just sign up at exacademy.com. You can have the personalized worksheet as well. You can have your own custom worksheets, and we do the work of that as well. Either you can post your queries to our website, or you can just email us at exactacademy@gmail.com. So that's it for today. Thank you. Have a great day.